So, ladies and gentlemen, last but certainly not least, we are going to build serverless end-to-end LoRaWAN solutions. So, if I learn one thing today about IoT is that you need to keep it simple. How do you do it when you cut out the server? Well, Sander van der Graaf is an expert on that because he's a cloud solution architect and he works for a lot of fintech companies or banks, as you will. And his talk will be building serverless end-to-end LoRaWAN solutions. Ladies and gentlemen, please welcome Sander van der Graaf. Welcome, Sander. Oh, you brought your own laptop,
yes,
so put it up.
Yeah. Hi.
And you even have a demo in there.
Whoa.
No?
If the demo gods are happy today.
Yeah, because...
yes.
Well, for me, I was notified that this conference was going to be messy because it's self-organized. Well, it's been going too smooth for me up until now. But everybody was in time. Yeah. And the technology worked, so please mess up because,
sure.
We need some fun, right?
Yeah, sure.
You're all set?
I think, yeah.
Oh,
yes.
Server is burning. Take it away.
That's a good start, right? Okay, hi. Welcome all. Yes, I think I'm the last speaker today, so I hope I'm not too boring and I'm not keeping you away from any beers or anything, so let's just get started. All right, so I want to talk to you about serverless LoRaWAN end-to-end solutions. And serverless is one of the technologies that I've been working on with for the last 2 years, which is a lot of fun. So, my name is Sander van der Graaf. I'm a cloud solutions architect. I've been working on large-scale applications for the last 15 years. And the last 5 years, I've been focusing on AWS solutions. So you'll see a lot of AWS in my talk. You might also know me as Dr. Bendu, which is a side project where we teach kids how to program with Python and Raspberry Pi, and we build awesome things to make them makers, which is really cool. So, what is serverless? Who in here has ever heard of serverless? Raise hands. Okay, who has ever done a project in serverless way? All right, I see some hands. Good. All right. To explain to you what serverless is, I have to give you a little bit of context. So let's start with that. So to give you a bit of perspective is that back in the day, we used to have physical machines in our data centers. We used to assemble these machines ourselves. We used to have motherboards, CPUs, memory. We choose the best disk in RAID, put them in a server rack, and be done. They would, of course, fail. We would have hardware failures, software failures, or memory failures, or whatever. So we thought, hey, maybe we can build something else and make them virtualized so that we don't have this hardware breakage, no disks failing, and that sort of stuff. So we came up with virtual machines. Whenever you need to scale out that application that you're running on those virtual machines, you just take another virtual machine, copy it, run it in 2 or 3 or 4 or whatever fold, and have a load balancer in front of it. So that's your unit of scale, is a machine. The next layer on top of that, the abstraction layer, is containers. So nowadays, the crazy thing that's always happening is like Docker. Docker everywhere. Docker is really cool. Or Kubernetes, which is even more cool. And in that way, you abstract away the machine. You don't care about the machine. You only care about the container. You don't care about the OS. And the unit of scale in that way, in that container, is your application. If you need to run multiple instances of your application, you just spin up a new container and another one, and another one. And as long as the underlying architecture just load balances all the requests to those applications in a certain way, then you're all good. So serverless is just another abstraction layer on top of that. So in serverless, you abstract away the runtime. You just tell, hey, if you deliver your application in a certain way to me, I will make sure that it's run when you need it to have it run. And in that way, you can scale functions. And that is the most important thing to remember about serverless. You can scale functions. So whenever you see in your application that one specific function gets a lot of load, you can just scale out that function horizontally. All right, so to put it in a bit of a perspective even more, VMs are, I want to configure machines, storage, networking, and my OS. I want to have total control over all of the layers. If you run containers, you just say, hey, I want to run servers. I don't care about whatever is running underneath it. I just want to configure my applications and control the scaling. And if you go serverless, you just say, I don't care about all of that. I just want to have my application run and have it run in the way that when it's needed. All right, so at the last Serverless Conf in New York, Simon Wardley, I always pronounce it wrong. Simon Wardley, yes. He made this nice map. He's a map maker, and he made a nice map to put things into perspective of where we got the serverless movement from. So we started at some point with a computing network. As I just told you, we had data centers with our own custom hardware, and then we started moving away into a more we evolved into a more abstract way. So I have to say that the horizontal layer is the evolution, and the vertical layer is the visibility on the value chain. Blah, blah. So anyway, so we have a compute layer where we started with just like physical machines. Then we virtualized more and more into like virtual machines. And then someone said, hey, I have CPU power available. I can just rent you out my VMs. And then we moved along even further. And we ended up with where we are now, cloud computing. So in the same way, at the same time, we also had the development of platforms. So at some point in time, we said, hey, we are developing our application. We are developing our application. And then we were saying, hey, but now we're developing this more and more, and we're just copying ourselves. Why don't we make this into a framework? And then at some point in time said, yeah, but my framework is way better than your framework. So I'm going to open source it, and you're going to open source it, and we're going to see which one wins. And that is what the one true framework. So we had like applications like frameworks like Python and Rails, or Django and Rails, and all those kinds of frameworks. And then we said, hey, if we host those applications, for instance in PHP, say WordPress, I can host WordPress for you, and you just have to provide me with the content and the blog and the data that you want to publish. And you don't have to care about your WordPress installation. I'll do that for you. I'll make sure that it gets updated and that sort of stuff. So that's the next iteration of development. And if you continue on that scale, you will see that you eventually end up with serverless. You just have to provide your functions, and we'll take care of the rest. Somewhere in between, there's DevOps, which is now the new legacy. DevOps was a buzzword. It still is. DevOps is a way in which you integrate your operations for your computing system with your software, which makes it perform better, or maybe optimize your application to run on that specific platform. Of course, when you're running serverless, you don't actually care about everything which is underneath it. You just want it to be run. So DevOps is actually now the new legacy, because in the future you won't even need it anymore. And I'm predicting that within now and the next 5 years, serverless is like the new standard, and maybe even already the new legacy. Because we also see something else coming up, which is, and now called Jeff. There's no official name yet for it, but Jeff, which is a coding standard, or a way in which you can deploy your applications in a certain practice or a certain best way of doing it, which is something for another talk. All right, so there's a nice quote on serverless by Martin Fowler. He has some really nice posts about serverless. If you want to read up more about it, I suggest you Google for it. He says, a serverless application is an application running on third-party services, BaaS, and or using serverless computing, FaaS. Say what? All right. Okay, so there's basically two different terms that you need to remember, BaaS and FaaS. BaaS stands for backend as a service, which means whenever you're running your application on a third-party, well, let's call it a delivery platform, which connects to your endpoints and your phones and your apps and whatnot, and you don't manage anything, you just put the content in, that's called the BaaS. It's a bit abstract, but it's really easy to get going, but it's really hard to customize. So if you want to customize things, you have to go into the FaaS side of things, and that's what I'm going to talk about. BaaS is really cool. If you want to start out with it, I suggest you look into it. But FaaS is where I'll be talking about, which is functions as a service. So functions as a service. There's different providers. These are the three biggest ones. So Google has cloud functions. Azure has functions, and there is AWS Lambda. I'm really focused on AWS Lambda, so everything that I'm going to talk about is about AWS Lambda, but know that there are other cloud providers out there who have the same set of features and functionality. All right, so that's all perspective and context and that sort of stuff. So why, if you want to run an application, why would you want to run it serverless? There's different reasons why. First off, patching. Who in here likes to patch servers? No one, right? No one comes in on the day, hey, yes, today I'm going to patch my kernel, and I'm going to deploy it into production, and everything is going to be fine. Nobody says that, ever. Maybe someone, but I don't know. Of course, recently we had the Meltdown and Spectre attacks, which were very hard. One of the clients that I work for is a hosting company, a managed hosting company. And of course, we had to manage all those instances and patch them. And of course, we automate everything. So for us, it's really easy to just deploy a new VM. Say to the client, hey, we have a new VM with all the patches involved. Can you check whether your application is running? And then they have to do their work, test all their application and all their patches and all that sort of stuff, and see if everything performs in the way that it needs to perform. But that's a lot of work. That's processes that you need to follow. That's procedures that you need to take off. That's compliancy that you need to follow and be sure that you do correctly. So why would you want to do that? So when you're running serverless functions, you actually don't need to care about that. When AWS announced their server security post where they explained that these attacks were happening, they also said, hey, if you're running Lambda functions, we already patched the underlying containers. So from that moment on, whenever you invoked a new Lambda function, it was already patched. You didn't need to do anything, because everything is abstracted away for you. Another important thing to know about serverless functions or Lambda functions is there are different runtimes that you can deploy your functions in. So there's C#, Go, Java, Node.js, and Python in different versions. And you can mix and match. So for instance, say you have your application running in Java, but there's one specific function where you maybe, I don't know, calculate the difference on a certain set of numbers. And you know that that's going to be way more performant in Go. You can just switch out that specific function for a function in Go and have it perform way better. Yes, that's very cool. Yes. One other very important aspect is that it's event-based. So each and every time your function gets evoked, it gets an event. So in the case of AWS, there's different types of events that it can trigger. So I highlighted some of them. So the first one is API Gateway, which is an API Gateway, which just listens to HTTP requests, forwards the request onto your Lambda function, and you get the whole request where you can act upon it. There's AWS IoT, very important. It can listen on changes for your device, the state of your device, and then do something. So say the temperature changed above 20 degrees. OK, run this Lambda function and do something. Or maybe we have, I don't know, we've set an alarm. The alarm triggers, send an SMS notification to the user. CloudWatch events, if you want to do something CRON-like, so say, hey, run this function on the second Wednesday after the first of the month, do that, or maybe just every month or every quarter. DynamoDB, whenever you store something in a database, trigger, or whenever something gets updated in a database, trigger, or whenever you delete something in a database, trigger. And S3, whenever someone uploads a file, a PDF, an avatar, or maybe, I don't know, insurance data or mortgage data, take that PDF, OCR it, and put it in a database, or send an email to a manager who needs to approve something. Very important. All right, another important aspect of serverless is that it's stateless. So as you can see, there's time, and whenever an event comes in, your function gets triggered, in this case, do stuff. It gets the event, and then it gets killed. And it doesn't know anything about what happened before it, and it will not know anything about what happened behind it. So let's put this in a bit more perspective. If you have multiple invocations of the same function, they don't know anything about what happened before, during, or after themselves. So you need to take care of that state yourself. And even better, if you have a function which doesn't actually need any state, which is a different way of thinking about developing your app. But in this way, it's really, really, really scalable. Which is my next very important thing, is that Lambda functions are scalable by default. So say you have an application which has a certain amount of traffic coming in, so the gray area, and you set your servers, you set up your servers, the amount of servers that you have, to a certain specific limit, say twice as much. So you buy your servers, you keep them running. You have, instead of 2, you have 4 running, so just to make sure that you handle all the traffic. And all of a sudden you have spikes. Oh, you have spikes coming in. And those spikes are really high. And they happen within, I don't know, a couple seconds. There's no way that you will be able to spin up a VM. There's no way you'll be able to spin up a container within those few seconds. So if you want to keep those customers happy, what you need to do is just instantiate more servers. So you'll have another layer of servers. So instead of 4, you maybe have 8 to handle all those extra traffic in just those specific points in time. So what does Lambda do? It just gets an event. So each time a request comes in, it just spins up a new function, runs the function, and is done. So whenever it needs, like, instead of 200, it needs 400 requests, it just fires up 400 invocations of your Lambda function. So you get scalability out of the box. So then you're going to say, okay, that's all fine and handy, but what is that going to cost me? So if you have VMs, you're scaling by VMs, you pay by the minute. Almost all of the cloud providers do this. Not only AWS, they were a bit late to the party actually, but you pay per minute, which is pretty good. You can just scale up and down, and you only pay for the amount of time that you use it. Lambdas, you pay per 100 milliseconds plus the amount of requests that you call that function, the amount of invocations. All right, so how much does it cost? This. So a very, 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 very small amount. So 0.0000208 cents per 100 milliseconds and 0.00002 cents per request. Okay, you say, yeah, that's all fine, but it's going to add up and blah, blah, blah. Okay, we'll see. Because you also get free stuff. Each and every month you get 400,000 gigabyte seconds per month for free. And you also get 1 million requests for free. So 1 million invocations for your Lambda functions are free. And 400,000 gigabyte seconds means if you have a Lambda function which uses a gigabyte of memory, you can run it for 400,000 seconds within that month for free. Now, if you go over it, you pay the amount that we just saw. All right, so let's give an example. Say you have a network with 10,000 devices in it. Each and every time, within an hour, they update their whatever, let's say temperature. They report the temperature each and every hour, but you don't know when. Could be that they're all coming at the same second in time. Could also be that they're spread out within the hour. You don't know. And each and every invocation of that function, or that trigger, takes 2 seconds to process, to store it in the database, to do, I don't know, send an SMS or whatever. If you go for a traditional layout, you would maybe spin up 2 VMs, have a load balancer and database server, and then spread that load over those 2 web servers, or whatever server you have. This is going to cost you about $250 a month. I mean, could depend on how you implement this. Maybe you buy cheaper servers, or maybe you just have more servers, or maybe you have a job queue server, or whatever. It doesn't really matter. It's going to cost you an X amount of money. If you go the Lambda way, you could just have an API gateway, and that triggers the Lambda function, which then stores it in the database. So let's say you have 7.5 million invocations per month, and they all take 2 seconds to process. The Lambda function will just scale out as much as you need it. So if there's 10,000 requests coming in at the very same second, you'll just have 10,000 Lambda functions running at that same second. How much is it going to cost you? 250? Who thinks 250? 250. Okay, who thinks it's lower than 200? All right, who thinks it's lower than 100? Okay, who thinks it's lower than 50? All right, it's $25. And if you raise this by 100,000 devices, it's about $350. So then you scale out by tenfold, but you don't scale out your cost by tenfold. It's a bit more, but it's very cheap. All right, so let's give you some examples of how a serverless variant of a implementation, what it looks like. All right, so very simple example. You have a web server serving static HTML pages. So instead of the VM, you just spin up. You don't spin up. You just store your data in a S3 bucket and have everything be served from the S3 bucket. No need to run a web server. Very simple example. All right, another example, a CRON server. Usually you have a CRON server running, a VM, which does something at a certain point in time, stores something in a database, and then goes to rest. The rest of the day, it does nothing. So the next day, at 12 o'clock, it just invokes again, runs the stuff, stores it in a database, but you're paying for those whole 24 hours, which it is doing nothing. What you can also do is have a trigger, which just triggers a Lambda function, which does the same thing, but only at that specific time that you need it. So it runs for maybe 5 seconds, does whatever it needs to do, stores it in a database, and dies. You don't pay for it the whole 24 hours, just those few seconds that you need it. Another example, job queues. So say you have a trigger, a process or a user or whatever, trigger a function on a VM, which then stores or sets a job in the queue. This is very, well, it happens a lot. So say you need to process, I don't know, a gazillion PDFs. You just store the list of all the PDFs that you need to run in the job queue. And each and every worker, in this case, these 3 VMs, just takes one PDF, downloads it, OCRs it, puts it in the database. The next worker goes, okay, picks the next one, et cetera, until it's done. But in between the time that those VMs are doing nothing, maybe there's nothing in the queue, you're paying for those VMs. It doesn't make any sense. So you can also just take Lambda. So have a function be called by API gateway that stores it in SQS, also a serverless service, and then have Lambdas trigger on those SQS events, saying, hey, I'll just have to start processing now. And when they're done, there's no Lambda functions running anymore. Whenever a new job comes in, immediately a new Lambda function got spin up and will process that task for you. Another one, this is very cool because it has a lot of arrows. So resilient uploading. Think a user uploads an avatar, which is not really resilient. I mean, if it goes down, that's fine. But think maybe insurance data or medical data. You want to make sure that whatever the user uploads actually ends up on the disk. And whenever that disk dies, you actually can still get it. So in this case, classical 3-tier system. A user uploads an image, goes through one of the 2 load balancers, comes onto the web servers, which then talk to the application servers, which then decide, hey, I'm going to store it on this disk. That disk is going to clone it to the other disk, and I'm going to store it in a master database, which is going to sync it to the slave database. Imagine what this would cost. Imagine what this would cost if there's a man actually managing these machines, or maybe 2 or 3, because the man gets sick or gets under a bus, heaven forbid. So you need someone to manage all this. You don't want that. You're only paying for those things that you actually don't need. So you can also do it in a serverless fashion. So say you serve the application through S3 and CloudFront, so it's a distributed system across the world, and the user fetches that application from your S3 bucket into his browser, and then the browser connects to your API, saying, hey, I want to upload a file. It says, okay, use this. It talks to the Lambda function and says, okay, use this generated URL. That generated URL is actually a signed URL, so it can upload in one specific spot on into another S3 bucket. Then there is a Lambda function triggered by the fact that there's a file uploaded in that bucket. So this function gets triggered, says, hey, I got a new file. I know it's from this user because I have a signed URL. I'm going to store it in the database for that specific user. Whenever the user comes in and refreshes the page and wants to see the file, it will ask to the API gateway saying, hey, can I see that file? Sure, it's in the database. I'll fetch the URL for you and you can see it. Which is a different way of looking at the same application, but in this case, there's no servers involved. So you don't have to maintain those. And whenever, I don't know, you want to extend it, you can just extend it with another function. All right, that's all fine and dandy. Let's see how does that look for LoRaWAN. Let's see how you would implement such a thing with a LoRaWAN dashboard for a typical, I don't know, IoT application. So there's this really nice thing in the Things Network. Of course, we're going to integrate the Things Network here, which is the AWS IoT integration. What this does is this will spin up through a CloudFormation script. So this is the Things Network, a AWS IoT integration, which is a server, remember that, which is a server running in your account, which gets triggered on each and every MQTT change. So then we can set up this server to whenever it changes something, trigger a Lambda function, store it in a dynamic database, and run the rest of the application as always. But of course, this is running a server, and we hate servers. We don't want to manage a server because the server can go down. We don't want this because this will always happen at Christmas Day when you're just eating. And that sucks, I can tell. So, fortunately, there's also an HTTP integration, and this is exactly what we need. So, instead of using the AWS IoT integration, we're going to use the HTTP integration. So there's a node pushing data into the gateway, into the router, into the broker, into the handler, and then the handler just calls the HTTP integration. All right, 5 minutes. Calls the API gateway, runs the Lambda function, stores it in a database, and a user can fetch the application and does the same thing. So it says, hey, what is the latest data for this device? Fetches it from the database and sees all the data. All right, so there's different frameworks that you can use. I'm going to rush a bit. Different frameworks. The most important one is Serverless framework. It's awesome. Go see it. It's multi-cloud. It's awesome. And I really want to do a demo. So let's pray to God that everything goes well. So this is the application that we're going to build, or that we'll have running. Let me see. All right, so I have this awesome application. This is my awesome things application. Where is my mouse? There it is. All right, so I have all the data for my device. So in this case, it has a payload of all the temperatures. Oh, you're not seeing anything. That's not handy. Da, da, da. Oh no. Da, da, da. Da, da, da. Mirror. There we go. You can now see it, right? Can still see it? Yes, all right. So I have my awesome application, my things application with a nice graph. Graphs are always cool. So I have my payload for my device and I graph it. So in this case, it's a temperature. Let me see, what else do I have? I have an application. In this case, it's a serverless framework application, which has a definition called serverless.yaml. I tell it that this service is called TTN serverless. Just give it a name. I tell it to use AWS. I tell it to use Python 3 because I'm using Python 3. I tell it to use these environment variables because those are important to do the actual uplink. And there's 3 functions, as I said. So there's uplink. Each time the TTN network posts something, it's going to use this one. There's downlink and there's log, which obviously does the things that it tells it to do. Let's not show that for speed. So how does it work as in uploading? So uploading looks like this. Serverless, not caps lock, serverless deploy. So what this will do is it will fetch the configuration, fetch my Python function, which is in the same directory, zip it, upload it to AWS. It will trigger an update of the stack, of the application stack, and it will configure all the Lambda functions. So let's wait for the dots to appear. All right, let's look up the things integration. Fatal errors, always good. So here's the integration tabs. I have an application called My Application. I have an integration, in this case, the HTTP integration. I tell it to use this URL. This is the output of the serverless deployment. I tell it to use this URL. I tell it to do use post, because that's what I configured in the serverless definition. I'm not using any authorization. You should, but I don't. And then I click save, which I won't do now, but that sets up the HTTP integration. And whenever something happens in the Things Network, it will be posted to that specific URL. So let's see how it works. I can do a simulation. Oh, there we go. So what I'm going to do is I'm going to echo 19.3. I'm going to, let's make it a bit bigger. I'm going to encode it in a bytecode string. And I'm going to push it to my device so that we can simulate that the device actually did something. So let's say 19.3. It calls the Things Network. Then the Things Network will call our endpoint. And we can actually see that. So if you go here, the last invocation, it is going to come in. Any second now, any second now. There it is. So this is the stuff that we get from the Things Network with our actually payload in it, which is raw, so it's encoded. Then we need to decode it, which is actually what the function does. So let's go into the uplink function. What it does, it loads the event, it decodes it, and then it puts it in the database. So let's look at my application. I have my application here, right? You already saw it updating, so I can do it again. Let's do it like this, and like this. Here's my graph. I'm going to push it, and then it takes a second maybe. Boop, there it is. And this is all happening without any servers running. So I just deployed an application with 3 Lambda functions. I just configured everything within the cloud. I didn't run any servers or whatever. It triggered the Lambda function, put it into my database, and then I have my client, my browser, serving this application from an S3 bucket without running any web servers, interpreting that HTML page, calling my API, saying, hey, what are the logs for this device, and then graphing it out in the database, or in the application. All right, that went well. Where are we? All right, so conclusion. Building a application in a serverless way is very cost efficient. It is event-based. It is stateless. And it's highly scalable out of the box. Those are the 4 things that you need to remember. If someone asks you tomorrow, what did you learn from this talk? That's it.
Awesome. Sander van der Graaf.
Yes.
My motto at conferences is always, if nothing goes wrong, you have taken too few risks. So it's actually pretty bad your demo went well.
Yes,
but then again,
well, yeah, I cut time. I wanted to share something else, but anyway. Yeah.
Any questions for Sander? Yeah, in the back. Oh.
Dun, dun, dun,
dun. Somewhere about here. Oh, there you are. Hello, who are you?
Hi, my name's Rick Timmis. The question I'd like to ask is, with the serverless functions, when you are developing a larger scale application, how do you approach source control and ongoing maintenance with your teams?
Yes. So the question, yes, exactly. So I've already heard the question, so I don't have to repeat it. So what you want to do then is split up that application into microservices. So have multiple services act upon itself. So you can easily replace something or work on something while something else just keeps on working. Does that make any sense? So the important thing is to split up your application in multiple parts and have different teams working on different parts of the application without intruding on other people's parts of the application.
Yeah.
All right?
Okay, some final question or remark or theory, advice, anything?
There's one.
Typical? Yeah, that's the last question over there. Hello.
Hi.
Who are you?
Hi. Jordi from All Sensing.
Ah, welcome.
Yeah. So how you see the future I mean, do you think there's a way that all the providers, like with Docker, they offer the same? I mean, you program once and you are able to deploy in different providers, not only in Amazon Web Service.
Yeah.
How is the future in 2 years about this?
So everybody's talking about vendor lock-in with your cloud. I actually don't think that's a real issue. Because what you're going to see is that you'll have your application, in this case, by Python functions, which is just a regular Python file with functions in it. So there's imports, there's functions, there's description of how things happen. And in the case of, if you're using the serverless framework, you could easily switch out the AWS part for, I don't know, Azure or Google Cloud. You maybe have to adjust some of your resources in your configuration, but you can, for the most part of your application, you could just deploy it into that other cloud, that other cloud provider that you want to. Yes, I think it's going to be easier, but it's not going to be platform independent, so to say. You're not going to say, okay, take the file, deploy it at the same thing in a different cloud provider. I don't think that's going to happen.
Okay. Well, thank you. Sander, before you go, when you're not Sander van der Graaf, but Dr. Bendo, teaching kids how to code, would you also be willing to teach them how the Things Network work, or only Python?
Well, Python is my first love, so yes. But the Things Network is really awesome, and it's really cool to integrate.
You think we can teach it to kids?
Yeah,
you ready for it?
Yeah.
Okay.
Yeah. All right.
Hope you're there. Final applause for Sander van der Graaf.